With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that there is a rod which is formed by joining two cylinders, each having a length and cross-section area S. Now the densities of the cylinder are rho and 2 rho respectively. The rod is now horizontally suspended in a liquid of density 4 rho with the help of a string as shown in the figure. Now the entire setup is kept inside a lift. Now for the quantities given in list 1, we need to find, or we can match the quantities in the this list 2. Now in the list 1, so it is asking for the tension in the this string 1 and 2 if the lift is moving upward with a constant velocity. And in R and S, it is asking for the tension T1 and T2 if the lift is moving downward with a constant acceleration g by 2. Okay. Now whenever we are in a lift system, we just treat our g as to be our effective g. So g would be equals to g effective, which would be equals to g this acceleration due to gravity, and then we would be having plus minus a, the acceleration of the lift. Now plus and minus sign, this would be decided by the pseudo force. So we will be just taking the direction of the pseudo force, and then we can just decide whether the direction would be positive or negative. Now first of all, we just treat this system. So if we just say for this system, what are the various forces which would be acting? So it is attached with a string. So tension force, if we just draw the free body diagram for this part, we are just drawing the free body diagram for this part. So tension force, let's say here it is T1, is string T1, and this is string T2. Tension force is T2 at this end. Now there would be weight of this liquid, this rod. So the weight of this rod would be acting vertically downward. Here also it would be acting vertically downward. What is the weight? It is mass into, we say that weight would be equals to m into g. Now what is mass? It is density into volume into g. Now what would be this value? So density of this rod is rho. Volume would be equals to, from here to here, let's say the length is L multiplied by the area multiplied by g. Now this g is g effective. So we just say that ge. This would denote g effective. Now in the second case, density is 2 rho. So it would be 2 rho into length is same L. This area of cross section would be S multiplied by g effective. Okay. Now there would be a bind force. Why? Because it is kept in a liquid of density 4 rho. So bind force would be acting. It would be basically acting at the center of the volume submerged. So the volume, if we calculate, so this is the volume submerged, the center would be somewhere here. So what would be the value of the buoyant force, FB? So buoyant force we just write here. Buoyant force is basically density of the liquid multiplied by this volume submerged multiplied by g effective g. So it would be equals to density of the liquid is 4 rho. Okay, what is the volume submerged? It is the total volume. What is the total volume? It would be equals to, the length would be equals to, from here to here, length is 2L. So 2L multiplied by the cross-sectional area. This would give us the volume. If we multiply it by g effective, this would be the buoyant force. Now we can say that the net downward force would be equals to net upward force. Why? Because it is in static equilibrium. So we can say that the net downward force, it would be T1 plus T2 plus this factor. So we say that T1 plus T2 plus what would be this? It would be 2 plus 1, 3. And other factors are same. So it would be 3 times rho L S G effective. This would be equals to the buoyant force which we have already calculated. It would be 8 rho L S G effective. So that means our T1 plus T2 value would turn out to be 5 times rho L S G effective. Let's say this is our equation 1. Now if we take torque about this end, let's call this end to be our A, this end to be our B. Now if we calculate the torque at this end, so net torque would be equals to 0. So we can say that tau net torque about A, this would be equals to 0. Summation of odd torque. So we just, first of all, we just write the value, then we will be equating it to 0. Now what are the torque? So we can see that this would be turning it into this. If we calculate the torque about this point, it would be turning in the clockwise direction, this also clockwise, this also clockwise, but this would be turning in terms of anti-clockwise direction. So for this torque would be positive. For this torque we are taking negative. So due to this it would be equals to rho L S G effective. This is the force multiplied by the length. It would be acting just at the middle. So it would be L divided by 2. Then comes our buoyant force. So buoyant force value, we already know it is 8 rho L S G effective, and where it is acting at a distance of L. So it would be in the negative because it is in the counterclockwise. We have taken the counterclockwise to be the negative. Plus our this weight, it was 2 rho. So it would be 2 rho L S G effective. This is the force, or we can say that weight. And what would be the distance? It would be L plus L by 2. That means 3L by 2. So it would be 3L by 2. Then plus the tension T2. So tension T2 is acting at a distance of 2L. So it would be T2 into 2L. This would be not 2L. So 2L, this is equals to 0. So from this expression, if we calculate, then our T2 would turn out to be 9 divided by 4 rho LSG. Now if you put the value of T2 into this expression, then our T1 value, this is G effective, T1 value would turn out to be 11 divided by 4 rho LAG effective. Now in the P option, in the P, it is given that this lift is moving with constant velocity. Now if lift is moving with constant velocity, so there won't be any acceleration. So we can say that G effective would be equals to G. That means our first of all, in the P we are calculating T1. So our T1 value would be equals to 11 divided by 4 rho LAG. Now in the Q option, for the constant velocity, so acceleration would be 0. So we can say that our T2 would be equals to 9 rho LSG divided by 4. Now in the R option, R and as well as in the S option, so it is given that lift is moving downward with an acceleration G divided by 2. Now this is the acceleration due to gravity G. Now if the lift is moving downward, so the pseudo force would be acting upward. It would be equals to G divided by 2. So what is the effective acceleration? It would be G minus G by 2. That means G divided by 2. So our T1, or we can say that T1 dash would then be equals to G effective value is G divided by 2. If you put the value into this expression, it would be 11 rho LAG divided by 8. And in the S option, T2 dash would turn out to be, we put the value of G divided by 2. So it would be 9 rho LSG divided by 8. Now if you match the option, so our P would match with this 3, and this Q would match with our 4, then R would match with 1, and this S would match with 2. So the correct option would be 3412. That means 3412. That means A is the correct option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.